We are absolutely swimming in data every single day. It's just a constant stream of noise. So, how do we find the signal? How do we find the meaning in all of that? Well, the answer is often surprisingly simple: a single, straight line. In this explainer, we're going to see how these lines of fit help us analyze relationships and make sense of the world around us. So let's start with a classic question. You've probably heard this one before, right? Maybe from your parents, maybe from a teacher. Is there a real connection between the hours you spend gaming and the scores you get on a test? It's the perfect real-world puzzle for us to try and solve with data.
And here's where it gets interesting. The numbers do suggest there's a link. But what kind of link is it? Is it strong? Is it weak? To figure that out, we're going to have to put on our detective hats. Our investigation starts right now, and we're going to follow the clues hidden in the data together. Now, our number one piece of evidence in this whole case, it's not a fingerprint, it's not a witness statement, it's a line. Just a simple line that tries to cut through all the clutter of our data points and show us the real trend hiding underneath. And here it is. This is our main clue. Now, don't let the math freak you out. This equation is just our model. In our video game scenario, X is simply the number of hours spent playing, and Y is the grade we're predicting. That number right there, the negative 9.6, that's the really crucial part. It suggests that for every extra hour of gaming, our model predicts a student's grade will drop by about 9.6 points. It's our mathematical story of what's happening.
So, where did this line come from? It wasn't just drawn at random. Nope, it was found using this really powerful statistical method called linear regression. You can think of it like a super smart process that looks at all the data points at once and figures out the one single perfect line that best represents the entire group. It's the mathematical way to find the average trend. Okay, so we have our line, we have our main piece of evidence, but is it actually a good piece of evidence? Is it strong, or is it kind of flimsy? How well does it really describe what's going on? In any good investigation, you have to check your clues. So let's see how we do that with data. The whole goal of linear regression is to find this exact thing, the line of best fit. I want you to imagine every single data point is like a little magnet, and it's pulling on our line. Well, the line of best fit is the one that settles into the most balanced position, the one that gets as close as it possibly can to all of those points at the same time. But what about all the points that don't land exactly on the line? Well, that little gap between a real data point, like a student's actual grade, and what our line predicted their grade would be, that's called a residual. It's basically just a measure of our error, of how far off our guess was for that one person. A really good line of fit is going to have really small residuals overall. And this leads to a brilliantly simple idea: the correlation coefficient. Instead of looking at every single little error, what if we could just get one single score for our line, like a report card? Well, that's what this is. A score close to 1 means you have a strong positive relationship. A score near -1 means a strong -1. And a score near 0, well, it means there's not much of a relationship there at all. So, what did our investigation turn up? A negative correlation. All that means is that in our data set, as the hours spent playing video games went up, the grades tended to go down. They move in opposite directions. The clue is definitely getting clearer. So, if our model can describe this relationship, can it also, predict the future? Can we use it to guess what a student's grade will be based only on how much they game? The answer is yes. But, and this is a big but, we have to be extremely careful about how we do it. The first way we can predict is called interpolation. Let's say our data covers students who play anywhere from 2 to 15 hours a week. If we try to predict the grade for someone who plays, say, 8 hours, we're interpolating. We're making a guess inside the boundaries of what we've already seen. It's a relatively safe bet. But what if we try to predict the grade for someone who games for 30 hours a week? That's way outside our original data range. That is called extrapolation. We're essentially guessing in the dark. We're stretching our line out into territory where we have zero data to back it up. This is where predictions can go spectacularly wrong. So here's the crucial takeaway. Interpolation is like reading between the lines of the evidence you already have. Extrapolation, on the other hand, is like writing a whole new page with absolutely no evidence to support it. One is a calculated guess, the other is pretty much pure speculation. All right, we found a connection. We've even measured its strength. But now we've come to the final, and honestly, the most important part of our entire investigation. This is the big twist, the one that catches so many people out.
Our source material offers up this very logical-sounding explanation. It suggests that because gaming takes up time you could have been studying, one might cause the other. It's a solid theory of the crime, right? A plausible motive. But it's not a conviction. Not yet. You see, for there to be causation, we have to prove that changing one thing and only that one thing directly makes the other thing change. It's a much, much higher bar to clear than just showing that two things happen to move together.
And this, right here, is the single most important takeaway from all of this. Our line shows a correlation. When one thing changes, the other tends to change too. What it does not do is prove causation. It does not prove that video games make grades go down. It just shows they're related in our set of data. That's it.
So I'm going to leave you with this question. We can see the link in the data. We have one possible reason for it. But what else could be going on? Could there be some third hidden factor that's actually influencing both gaming time and grades? This is where a simple line of fit ends and where your own deeper critical thinking really begins.